Welcome to today's lesson. My name is Samasaka Kriandens. I'm going to take you through a lesson on organic chemistry, and in particular, we'll look at actually the manufacturing of our alkenes. And so we go straight into the lesson. Well, during the manufacturing of alkenes and hydrogen, we do actually use the process known as clacking. And clacking is the process that actually splits long chain alkanes into smaller chain alkanes, as well as producing hydrogen. This is very important because we have very large molecules and with long chains of actually alkanes. And these alkanes are broken down into smaller chains of our alkanes, alkenes, and hydrogen. And so this is very important because actually it makes the actually the alkenes which have double bonds. And so this is the process known as actually cracking. Again, cracking is actually breaking down large molecules of alkanes and breaking them into smaller molecules of alkanes, alkenes, as well as hydrogen. And so I will give an example of actually one of the cracking methods. For example, if you have butane and you heat it at a very high temperature, say 1000, you will produce a smaller alkane, which is ethane, and plus actually an alkene, which is ethane. So you notice that here, actually, the number of carbons does not increase as well hydrogen. So there are 4 carbon atoms here, and this side also from the product side, we have 4 carbon atoms, 2 and 2. And for hydrogen, we have 10, and this side we have 6 plus 4, which is 10. So that's why we are saying actually, when you actually crack a very large molecule, say butane, you get a smaller molecule, ethane, and ethene. So this is the cracking process. In the laboratory, actually, we can do the cracking process of an alkane so that we can produce an alkene and hydrogen. And in particular, I've given an example here where we have in the test tube here some paraffin oil here, which contains ethane. And here we have also F, which is actually the polar spot. Basically, this one is just for increasing the surface area for the reaction. And then you have the silicon oxide as a catalyst. And then this is merely the heat. And then this is the delivery tube. And then in this test tube, we are collecting actually 2 gases, hydrogen and ethene. And so in the beaker here, we have actually water. Okay. And so I will explain all these again. What we have there, I said W is actually water. And then A is ethene and hydrogen. That is in A, what is collected is ethene and hydrogen. And then in paraffin oil, actually that's where the ethane is. And then we have the heat. And then silicon oxide or aluminum oxide. These are actually the catalysts. They aid or they facilitate the reaction. And then we have the delivery tube through which the gas which is produced it passes through actually. And then we have the polar spot, which just basically increases the surface area for the reaction. And so there are 2 types of cracking methods. The first one is known as thermal cracking, Thermal cracking actually requires very high temperatures of up to 100 degrees and up to about 70 atmospheric pressure. And actually this basically is there to produce um, energy intensive actually products. For example, polyethylene plastic, which requires elevated temperatures up to about 1000. So that is the thermal cracking. And then we have the catalytic cracking, which actually has lower temperature of about to 450 degrees and also lower pressure. Well, actually, catalytic cracking is very, very advantageous compared to thermal cracking because actually the produced branched alkanes can easily burn, and therefore it is ideal that we use the cracking method, as well as the temperature, which is actually lower, and the pressure, which makes it to be very economical because it's cheaper, as well as producing the arenes like Brazil, which actually are the feedstock for the chemical industry. And so these are the advantages of catalytic actually cracking. And so if we look at actually the equation through which actually ethane is cracked, so we have an alkane and it requires a catalyst, say silicon oxide, and the process is actually cracking, where we have actually to break the very large molecules into smaller molecules of an alkene and hydrogen. In this instance, we are looking at the cracking of ethane. So ethane, when it is actually cracked, it requires a catalyst, silicon oxide, and it will produce ethane and hydrogen. And so this is the reaction. So the atoms remain the same. So we have two actually carbon atoms within the side of two carbon atoms, and have 6 hydrogen atoms, and the side have 4 plus 2, which is 6. So this is the process of actually catalytic kind of cracking, which is for ethane. And so here is a simple question which illustrates exactly what we have done here. For example, ethane can be cracked in the presence of a catalyst. Write an equation for this equation, give suitable catalyst for this reaction, state 2 types of cracking of alkanes, and state 2 advantages of catalytic cracking. And so this is the equation. Actually, we wrote it already, where we have ethene here cracked into ethene into ethene, and also hydrogen is produced. And we require a catalyst, silicon oxide. Okay, and so number B was asking us to give a suitable catalyst for this reaction. It is actually silicon oxide. And number C, give 32 types of cracking alkanes. Actually, the 2 types are thermal and catalytic cracking methods. And then what is the advantage, 32 advantages of catalytic cracking? Actually, the advantage, as we stated earlier, it produces blanched alkanes that are easily bent. That is catalytic actually cracking. And the lower temperatures actually make it cheaper or economical. And so I thought you would look at the alkenes, how we can actually manufacture them. So in the next lesson, we'll look at actually the properties of alkenes as well as how they react. And so there is a promotion here where I'm actually urging those who would want to have intensive and more solved questions, and those which are course tailored online can contact me through my email address, which is kcyamasaka@gmail.com. All these are small case letters. So if you want more of these lessons and tailored to your course you are doing, you can contact me. I thank you.